Can you really extract DNA from an amber-encrusted mosquito? Can you really deflect a meteorite with a thermonuclear weapon? There is perhaps no other genre of film, television, or literature that comes under as much criticism for its accuracy than science fiction. And with one of the most hotly anticipated sci-fi films of the year being released this weekend, I think it's about time we asked, why is that? This is Pamela Conrad. Pamela is an astrobiologist and planetary scientist. She's currently working for NASA Goddard Flight Space Center in Greenbelt, Maryland. So there's perhaps no one more qualified to talk about the realism of Hollywood sci-fi blockbusters than her.
Science fiction movies are really important because they change the narrative and they expand the realm of our imagination. And sometimes we get so caught up in what we think might be possible or plausible as we plan experiments, we don't dare to try the impossible. And science fiction movies remind us to do that.
There's an organization in Los Angeles known as Science and Entertainment. It allows sci-fi writers to connect with real-life scientists to help them with the accuracy of their scripts. It's an organization that's been involved with several recent sci-fi films, including Christopher Nolan's 2014 sci-fi epic Interstellar. The film not only brought $675 million to the box office, but it also advanced our understandings of black holes. This was, in part, due to Christopher Nolan's unrelenting drive for realism. For the film, Nolan brought on board Kip Thorne, an astrophysicist from the California Institute of Technology. Thorne, along with 30 visual effects artists and thousands of computers, created the most accurate simulation of a black hole ever. The findings of which were published in the scientific journal Classic and Quantum Gravity in 2015. The work involved to make this special effect was intense. The visual effects company had to create a whole new different type of rendering software. The computing power needed to create this simulation meant that some frames would take 100 hours to render. For some context, the video that you're watching right now is showing 24 of those frames every single second. In the end, the effect alone came in at a staggering 800 terabytes. But I guess that's the price you pay for scientific accuracy. But there was another film that came out in 2015 that also received its fair share of attention from the scientific community. Both critically and commercially acclaimed, Ridley Scott's The Martian was widely regarded as one of the most scientifically accurate films of all time.
Mark Watney's still alive.
Woo! In your face, Neil Armstrong.
But just how accurate was it?
Look, I don't mean to sound arrogant or anything, but I am the greatest botanist on this planet. So.
The potato thing was a little bit of a problem. What we know about the very fine, silty stuff on the Martian surface is it's full of a very oxidizing material called perchlorate. And that stuff it's kind of like having the surface of Mars covered with Clorox. So it's more than just that it's very, very fine and doesn't have that network and porosity that would hold on to water. It's that it's got bad chemicals in it. The second problem is that the kind of gut bacteria that you would find in human poo would essentially not be viable as a product that would metabolize the soil. It might work on Earth, but Earth is a different set of conditions than we have on Mars. But that being said, the author worked really hard to be as scientifically plausible as one could be. But I think based upon what we learn every day as curiosity studies that surface material, we're a little bit far off of potatoes, and maybe another mechanism for growing them would be more fruitful. Maybe hydroponics.
Yeah, they upgraded their estimate. The storm's going to be a lot worse.
So the Martian atmosphere is very tenuous relative to the Earth's. And we do know that there is wind and there are clouds and dust devils and there are dust storms in a particular hemisphere of Mars at a certain time of year. but it doesn't get to be that bad. And it doesn't get to be that bad for a number of reasons, one of which is it's a thin atmosphere. You couldn't raise such a huge bad load with that thin, kind of weeny atmosphere. You do get wind, and you do get pounding with sand, but not enough to knock over a rocket.
Ever since our voyage of love began, your touches thrilled me like...
It's really hard to know whether Pathfinder would have been salvageable that many years into the future. We don't know to this date exactly what failed on it. Typically, in the dust environment of Mars, mechanical parts fail before electronic parts. But we don't know. So because we don't know, we can tell a tale, and it feels believable to me. The one thing I would say that doesn't work well for me in that regard is picking up the multi-mission radioisotope thermoelectric generator, which is radioactive, and sticking it in the rover and not dying of radiation poison.
And Pamela would know. She's the deputy principal investigator on NASA's Curiosity rover. And she's also working very closely on NASA's Mars mission for 2020. For me, the greatest achievement in realism that came from The Martian was its portrayal of scientists. Too often in big-budget sci-fi films, scientists are portrayed as robots more than humans. Dorky, calculating, antisocial, and rarely funny.
You see, your words sound reasonable, but your face looks angry.
But The Martian's Mark Watney is a break from this trope, and a more realistic look at what scientists are actually like. And just to prove my point, I think I'll let Pamela sign off.
In a distant past, I used to classify scientists and engineers as kind of nerdy and boring. And what I've learned is there's really no difference between scientists and engineers and the artists I used to hang out with when I was a musician. I think scientists run the gamut, and that we have been a little bit unfair. I loved the way Matt Damon played Mark Watney, because that's like guys I go to the field with.